Every month, the shared family phone bill drops, and every month, someone has to open a dense, multi-page PDF to figure out who owes. You are hunting through tiny rows of text to calculate device installments and shared data pools, then opening your bank app to type out individual Zelle requests. It is a repetitive chore that practically guarantees a typo eventually. The TMO pipeline eliminates that loop entirely. It's an event-driven automation handling the calculation, messaging, and actual money transfer without a single human click. Building a financial handler from scratch usually takes weeks of trial and error, but this system was engineered exclusively through AI-native pair programming. This chart shows the 3-day AI development cycle, measured against the estimated 9 days of manual labor saved. Using DeepMind's Gemini to write and review logic, AI contributed 75% of the final codebase, compressing a multi-week build into a precise sprint.
Solving mundane financial chores is a systems engineering problem, not a personal time management one. The workflow starts quietly. A scheduled macOS launch agent acts as a silent watcher, waking the local system on specific days of the month. It checks the telecom provider's portal, and the exact moment a new bill is posted, it downloads the PDF directly into a local directory. Once the file hits the drive, an extraction engine takes over to process the raw document. Instead of a human scanning for numbers, a Python script slices through the layout, isolating the specific dollar amounts tied to each individual phone line. It instantly groups the special pool variables, like device financing or shared subscriptions, and calculates exact fractional splits in milliseconds. Transforming unstructured visual documents into strict mathematical arrays is the required first step for reliable automation. Doing math is one thing, but actually moving money requires strict programmatic safety constraints. The code uses a concept called item potency, meaning it can safely run multiple times without repeating an action. It does this by writing its current status to a local JSON state file, tracking exactly where it is in the monthly billing cycle. If the workflow crashes mid-execution, it doesn't blindly retry and risk a duplicate payment. It reads the state file, identifies the anomaly, and emails an alert. It also checks against a hard-coded amount cap, instantly aborting if the bill spikes unexpectedly. A financial script is only safe for production if its failure modes are explicitly engineered to fail gracefully. With the calculations verified, the pipeline moves to the outbound phase. First, it emails a clean, formatted cost breakdown to everyone on the plan. Next, the script opens a browser profile and programmatically logs in to Bank of America to initiate the exact Zelle transfer. This is where banking automations usually hit a wall: multi-factor authentication. Banks send a text message code to verify your identity, which typically requires human intervention. To bypass this organically, the pipeline's underlying Python binary is granted full disk access within macOS. That elevated system privilege allows the script to read the bank's one-time passcodes directly from the Mac's local SQLite messaging database, fetching it instantly. The code autofills the extracted passcode, verifies the recipient's name, inputs the precise parsed amount, and executes the transfer. Securing system-level file access transforms rigid, user-facing security checkpoints into seamless programmatic pathways. The friction of hunting down line items and chasing payments is gone. The entire process now happens silently in the background while you sleep. The deployed pipeline runs with zero human intervention and perfect computational precision, month after month. This chart shows the development velocity behind the project. By leaning on AI-native tooling, the developer processed over 90,000 tokens across just 40 commits, turning a complex, multi-service integration into a brief sprint. Working alongside an AI shifts the engineer's role. You spend less time manually typing strict syntax and more time designing resilient, overarching system architectures. True automation inherits our routine burdens entirely, moving from simple manual assistance to a state of complete autonomous execution. You can review the state logic, inspect the data pipeline, and explore the complete architecture for yourself at the project.